Hello, hello. We're going to go over 178, 9, 180, 181. If we can fit them all in, let's do it. 178 states a state employee service has certain state certifications of typing speeds. Suppose the typing speed is normally distributed with a mean of 55 and a standard deviation of 4. Okay, so then this tells us that within one standard deviation, so mean 55, standard deviation 4, and similar to the last question, we know the area under the curve. So the area under the curve to the left of this value is 0.95 because they said that her score was really good. It was in the 95th percentile, which means she's super fast. So I already know that the answer has to be D or E because it's a number greater than one standard deviation from the mean for sure. So now I'm going to take a look at this. I know the area under the curve and I know mean and standard deviation. So I'm pretty sure that I can use inverse normal. And I tried to use it a minute ago to double check. And so let's try it again. Statistics, distributions, inverse normal. I know the area under the curve is 0.95. I know the average typing speed is 55. I know the standard deviation is 4. I hit enter. It says 61.6. That would round up to 62, and guess what? That's our answer. There it is. Now you can do this with your table A if you want and use the formula AP statistics. Either way works. You can do both ways, using one to double check. Next question, it says a new dietary supplement was given to a volunteer group of 25 people. So it's an experiment. The treatment was a dietary supplement. All right. So it looks like we gave 25 people the dietary supplement, and we gave it to people who were overweight because we're interested in finding out if it would help them lose weight. Out of the 25, 18 people lost at least 20 pounds. What can we conclude? Well, the problem here is everyone got the dietary supplement. And you know that you're swallowing a pill, so you could, in essence, think you're swallowing something that would work. And this is this idea of a placebo effect. Human beings, if we take medication that we believe works, then we make that a reality. So the problem here is that I'm going to have to circle D. We can't really confirm anything because we didn't have a group that got no treatment. Now, we would have maybe been able to compare an old diet pill to a new diet pill, but we can't just give everybody the same supplement and figure out if they lose weight. We could give everybody a Tic Tac, and we'd quickly find out that if we told people that Tic Tac was a diet pill, people would lose weight. And that's this placebo effect. 180, a pharmaceutical company developed a new medication to lower cholesterol. The advertisement of the new drug cited the results of an experiment comparing the drug with a placebo. So we like this. We compared the drug with the placebo, and it stated that the average cholesterol was lowered, and they got a p-value. So it looks like with that rare of a p-value, we would say we would have sufficient evidence to conclude that the medication is effective. So, but what in fact does it mean, this p-value? And so technically it means if we perform this thing many times, and if in fact H sub O was true, then this would be our outcome mathematically less than 1% of the time. So when I'm looking at my answers here, the difference between the group was not significant. That's not what we concluded. It was in fact significant. all but 1% experience a drop. That's not what that is at all. In fact, enough of the people considered a drop and we got a very rare outcome. 1% of the people did better with the placebo. That's not what that means at all. Only 1% experienced side effects. Again, that's not what a p-value is. So all of these don't talk about a probability, and in fact, it's got to be C. C is the probability. We're finding that a p-value is stating that the probability is less than 1, and that would be the probability of obtaining a difference between the mean cholesterol level and those taking a placebo versus those with medication is as large or larger than 13.2 if the mean and the medication groups were equal. So that's basically saying if H sub O is in fact correct, this outcome would only happen, at least as large of that kind of a measurement, would only happen less than 1% of the time, which is why it's so rare. It should in fact prove that, give us significant evidence toward this new medication. Now, 181. This is a very interesting question. I said that a moment ago. I haven't seen a question like this in a really long time. So they don't really tell us what X is. So I'm just going to call it X, E-X-E, a word X. And then I don't know what Y is. So I'm going to call that W-H-Y. Just so that I could, because I know I'm going to have to put this in a fancy calculator. And I know I'm going to have to label what I'm naming stuff. So let me just reduce the brightness here so hopefully you guys can see this. So I'm looking at my fancy calculator here. I'm going to the main screen and I'm saying to myself, I need a table because I need to type in these values. So my X values, I'm going to call it EXE, are, because I don't know what it represents, is 1, 3, 5, 7, 9. So those were the X values that were given to us. Cool. And then I'm going to call these my Y values, W, H, Y. I don't know why they didn't tell me what the Y values were, but I'm just going to call them Y. Those values are 11, 7, 2, 1, and -2. So I've entered in my X and Y values. And now I'm going to go back out to my home screen and I actually want to graph these so I can graph them using the purple bar chart. So I'm going to select that. Looks like my calculator is about ready to go dead. Luckily I have another one sitting here. Okay, so here's my values and I'm going to move my little mouse down here. I'm going to call this my X values, EXE. And wiggle over here. These are my Y values, WHY. Bam, I got myself a line. So they're asking which point would the residual be the largest absolute value. So that's actually code for which dot is farthest from my least squared regression line. Okay. So I need a least squared regression line, don't I? So you go to menu, analyze. Notice there's a little miniature picture of what looks like somebody putting a least squared regression line. And then there's the word regression. So that's what we want. I'm going to select that. And again, in stats, instead of choosing y equal mx plus b, we like this second one. So we're going to pick that one. Bam! I got myself a least squared regression line and a formula for it. Awesome. And so it looks pretty obvious that it is dot C that is furthest from the line. It would have a negative residual. It's below the line, but it's definitely the dot that's furthest from the line. And that's, in fact, our answer to 181. C would, in fact, have the largest absolute value of a residual because it is the dot that is farthest from the least squared regression line. Thanks for joining us.